A 72-kilogram man stands on a spring scale in an elevator. Starting from rest, the elevator ascends, attaining its maximum speed of 1.2 meters per second in 0.8 seconds. It travels with this constant speed for the next 5 seconds. The elevator then undergoes a uniform acceleration in the negative y direction for 1.5 seconds and comes to rest. What does the spring scale register A before the elevator starts to move, B during the first 0.8 seconds, C while the elevator is traveling at constant speed, and D during the time it is slowing down? Okay, so this is chapter 5, number 33. We're going to start off by writing out the givens. Since we know the man is on a spring scale in an elevator, and we know the man weighs 72 kilograms, we're able to find the force of him standing on the spring. The elevator will be rising at 1.2 meters per second at its maximum speed. So since the formula to find force is equal to mass times acceleration, we have to find the acceleration for the different time periods. For the first time period, at t equals 0, the acceleration will be equal to the force of gravity, which is just 9.8 meters per second squared. During the next time period, from t equals 0 until t equals 0.8 seconds, the acceleration will be the cumulative number of gravity plus the acceleration of the elevator, which in this case will be 9.8 plus the velocity of the elevator over this time period, 0.8. We solve this out to get 11.3 meters per second squared. During the next time period, the elevator is moving at constant velocity. So from 0.8 seconds until 5.8 seconds, the velocity is constant, meaning there's no additional acceleration. So the acceleration will be equal to force of gravity again, which is just 9.8. During the final time period, the elevator is actually decelerating. So from 5.8 seconds to 7.3 seconds, the acceleration will be negative. And in this case, will be gravity minus the acceleration of the elevator, which will be 9.8 minus 1.2 over 1.5, which is the time period. And this solves out to be 9 meters per second squared. So now that we have all of the accelerations for the given time periods, we can plug these into the formula to solve for the actual force. So for A, we're going to use F equals ma, and since it's not moving, it'll just be 72, or the mass of the man, times the acceleration of gravity, which is 9.8. This solves out to be 705.6 newtons. For part B, this is while the elevator is accelerating upwards, so we have a larger acceleration. So this turns in 72 times 11.3, which solves out to 813.6 newtons. For part C is the same answer as part A, because while it's not having any additional acceleration, it'll just be the mass of the man times gravity again, which comes out to be 705.6 newtons. And for part D, while the elevator is decelerating, we'll get a smaller answer, because it'll be a lower overall acceleration, which solves out to be 648 newtons. And that's how you solve chapter 5, number 33.